Welcome back to my exhaust fan controller project series. In this video, I was going to show exactly how to build a board in Circuit Maker, but my footage for that actually was corrupted, so I apologize for that. I'm going to show some pieces of that process, and I'm going to show the finalized board design, as well as an example of what I actually built. Currently, I've already put the board together, and I put it into use as the fan controller, and it's working great. This is the original design that I built. You can see the switch that I added in and all of the wiring that I did on camera. And this is the board that I put together for the more professional version. I chose to go with through-hole components, even though I didn't really have to. A lot of the time, whenever I build a custom board like this, I'm going to do everything in surface mount to make it as small as possible. But there were a couple of reasons why I chose not to this time. One of them was that I was using these really big connectors that take up a large portion of the board already, and I had a lot of the more expensive components already purchased in through-hole, so those were ones that I was just going to go ahead and use what I had on hand, and I figured that was easier. Additionally, I use through-hole resistors because I have a lot of those on hand too, and I could swap those out very easily if I decide to change a value. Now, the program I'm using to make boards is called Circuit Maker. This is freely available, created by the people who make Altium. All you need to do is sign up, and then you can create an account. The one downside about this program is that you can only have one private project at a time, but really if you're making little one-off boards for yourself, that's not too big of a deal. Making them public for other people to see is fine. You can see my design here. This is the same circuit board that I was working with before, but I've added just a couple of minor things. First, I added these two capacitors. So I have a bypass capacitor for the op amp, and I have a capacitor at the output here. So really, these are just to provide a little bit of extra stability for the supply on this board. I don't think they're really necessary, especially considering that the prototype board didn't have any capacitors on it and it worked perfectly fine. But I figured if I was going to be designing this, I might as well do it right, and added those in. In this design, I had to create several components, and one component that I did not create myself was my power plug. I figured I would just pick one that someone else had created and use that, and that was a mistake that I made. So whenever we go in and look at this part, you can see that this part has a schematic symbol that looks very good, and it has a footprint that looks very good. In fact, if you look closely at this footprint, it has a 3D model on it. And here's the 3D model, and the 3D model matches the actual component perfectly. Now, what I did not look very closely at was how large these pads are. And you can see here that they are very tiny. There's very little room to actually solder these in place. And additionally, there's no hole here for this pin that comes out of the bottom. Fortunately, that pin is just made out of plastic. It's really easy to just snap off or file off. And that's what I did on mine, was I just snipped it off of there and stuck it right on the board. But if you wanted to make this a bit more professional, you'd want to go in and update this footprint to be correct. A lot of the components are not exactly what I used. For example, these 100 ohm or 100K ohm resistors, all I really did was just grab something that was through hole, and I looked at the footprint, which was just 2 holes in the board, and made that as simple as possible so that I could put whatever resistor I wanted on my board. Maybe in a future design, I'll show actually selecting components and selecting the correct size of resistors, things that are going to be easy to do surface mount soldering on. But in this one, I wanted to use a lot of the components that I had available to me, especially the resistors that I have, because I have quite a few through-hole resistors laying around for different reasons. And I just use those to fill in the gaps here. I actually ended up using, for this pull up here for R2 and this R out, I ended up using 6.8Ks instead of 10Ks because I had a lot of 6.8Ks laying around, and that doesn't really make a difference, especially considering that I didn't include the switch that was in the prototype design here. I found with the real device, I never use that switch. It just kind of hangs out there, and switches are not cheap. So I figured that I would just leave that out of the final design. Now looking at the actual board design, you can see that I did not put 3D models on everything. I did get pretty nice 3D models for my potentiometers that I put these in here, and I can show an example of how to do that. I also put the 3D model in for this screw type terminal connector, and this is the one that someone else had created down here, and these MOSFETs were created by someone else as well. Fortunately, those worked out okay. The PDIP device, of course, you can see that's a really simple 3D model. And honestly, I didn't really care about the 3D models. I just kind of like having them, especially on these connectors. It's nice to see how big they are, where they're going to sit against each other and such. So on the other side of the board is where I put my bypass capacitor. This is the only surface mount component on the board. And I just happen to have a whole bunch of 1 and 0.1 microfarad capacitors running around that I can stick on here very easily for bypass. I don't really like to go back and forth between my computer and my board whenever I'm soldering together a design. And I find it easier just to mark directly on the silk screen what I need to put where. On this one, I marked R470K and R100K, so those are pretty obvious what go in those two locations. And then Rout and R2 I knew had to be about 10K ohm, so those were really easy as well. D1, I just marked the negative side so I would know which direction to put my diode. The capacitor is the same way. I put a mark on the negative side of this electrolytic capacitor. And my MOSFETs have a small dot next to them for the marker of pin 1, and the same on my LM34 temperature sensor. The potentiometers don't really matter which way they go actually. They're just three pins in a line, but I put them this way so that they would be turned up clockwise and turned down counterclockwise. And the only thing on here that was kind of ambiguous was the fan connector. I actually had to go double check this one whenever I was putting things together. It's pretty easy to see on the traces here that the output, this is the negative connection of the fan, is going to go to the drain of this MOSFET, the center pin of this MOSFET. The positive supply that goes to the fan is going to go to the negative side of the diode. So both of those are good indicators of which way that fan connector goes. It's just easy to forget which way around the connector goes, whether it has the tab on this side or on this side. And even now, after I put it together, I forget exactly which way it goes. So that's enough staring at this. I decided to start by putting the surface mount capacitor on the back of the board since that was the only component going on this side, and it would be easier to start with this. You can see me fight with this capacitor a little bit. Give me some credit because it's actually pretty hard to be able to film this and solder it at the same time. You can see that it was a little off straight, so I had to adjust it, and then the one I pull up close, you can see that it's on there very well, and I even checked it to make sure it wasn't shorted underneath, because anytime I'm doing something like that with a really big solder tip and without any magnification, I want to just double check that I don't short it out by accident. What I didn't show here was that I actually accidentally filled one of those holes with some solder when I was doing the capacitor. So I had to heat it up and pull that solder out with a solder sucker, but it was just a couple seconds to get that done. I like to have my solder hanging up in the air like that. It feels like a third hand whenever you're trying to solder this kind of stuff. You can use the clamps to hold it in place and then hold the solder yourself, but a lot of the time this is faster for me to just hold the components with a finger and then tack it on that way. And you can see I'm pretty used to doing it this way. It works pretty well for me. You shouldn't really clip off all three legs of something the way I did there. That can add undue stress to the solder joints. But for this little project, I'm not too worried about it. If I run into problems with it, I'll know where to look. That MOSFET also had a bit too much solder on one of the legs, so I expect that might give me trouble in the future. And to fix it, I would just resolder those joints. And this DC power adapter was a pain to get on here because of how small those pads are I mentioned earlier. I actually ended up with about 1 ohm of resistance between the pin and the power traces on this board. But since I put so much capacitance on the board, it doesn't really make any difference. So anything that needs to draw charge quickly can just pull off of the capacitance on the board. I mentioned earlier that fan connector, it was hard to figure out which way it goes. So that's mostly because I forgot which pins on the actual fan side of the connector go to power and to ground. So I had to go hunt down an actual fan connector and look at it. I could have Googled it, but I didn't really want to turn on my computer for that. This was all done at my bench with my computer off. And that connector is actually pretty hard to position there. I was trying to get it as close to the edge of the board as possible and even, but whenever I turned it over, it separated a little bit from the board. So when you look at the final version, you can see that it's just a tiny bit up on one side. Again, that's not really going to make much of a difference. It'll work fine. And these are the last couple of components on there, and trim that off, and then we can look at the final board. Really, the only thing left to do after this is going to be to clean the flux off the bottom of the board and then plug it in and see it work fine. Unless any questions or issues come up, this is going to be my last video for this project. So if you have any questions, please post them to the comments or send me an email. My email is electronicswithemrys@gmail.com. You can put dots in there, electronics.with.emrys. If you didn't know, the dots don't matter in Gmail addresses. So thanks for watching, and hope to post another video series in the not too distant future. I haven't really decided what I'm going to do next.